Good evening, Charan Sai. Let us wait for few more minutes so that the remaining students may join. Hi, Sahiti. Hi, Vamsi. In this live class, I am going to discuss few topics of acids and bases. So, what is the major concept of today's class? That is acids and bases. Especially in this live session, I am going to discuss in detail about the Bronsted and Lowry theory of acids and bases, followed by pH and buffer solutions. So initially, let us move on to the Bronsted and Lowry theory of acids and bases. So, Bronsted and Lowry theory is totally based upon the proton concept. So, depending upon the proton concept, all the substances can be classified into two categories. Coming to the acid, acid is a substance that donates a proton to the other substance. So, acid is a substance that donates a proton to the other substance. For example, when you consider HCl, when it is mixed with water, this HCl is capable of donating a proton to the water. Then it becomes Cl minus plus H3O plus. So here HCl is donating a proton to the water and hence HCl is called as Bronsted acid. Clear? Moving to the base. Base is a substance that accepts a proton from other substance. So what is the nature of a base? Base is a substance that accepts a proton from the other substance. So let us consider one good example, that is whenever ammonia is again treated with water, then what happens? This ammonia gains a proton from the water and results in the formation of ammonium ion. So in that context, ammonia is a base. Coming to the neutralization reaction, the reaction which involves the transfer of proton from an acid to a base. So neutralization reaction involves transfer of a proton from an acid to a base. So let us consider one more example, that is whenever HCl is treated with ammonia. Here what is the nature of HCl? It is an acid. And what is the nature of the ammonia? It is a base. So definitely a proton will be transferred from an acid to a base. Then it results in the formation of Cl minus plus NH4 plus. So this is good example for neutralization reaction which involves the transfer of a proton from an acid to a base. Clear? And always remember here acid base reactions are reversible. So acid base reactions are reversible. So when you carefully observe HCl and Cl minus, NH3 and NH4 plus, what we can observe? So let us see these two pairs. For example, when we consider HCl, Cl minus and ammonia and ammonium ion. So what is the difference between HCl and Cl minus? Try to answer. What is the difference between HCl and Cl minus? Amma, try to answer. Yes. So the only difference between HCl and Cl minus is a proton. Similarly, what is the difference between NH3 and NH4 plus? Again H plus. So an acid base pair differing by only one proton is called conjugate acid base pair. So a conjugate acid base pair will differ by only one proton. If we carefully observe the above example, so HCl and Cl minus will differ by only one proton. So it is HCl minus is the conjugate base of HCl. So it is acid one and its conjugate base is Cl minus. Ammonia is base 1 and its conjugate acid is NH4 plus. It is the conjugate acid 2. Clear? Always an acid base pair differing by only one proton is called conjugate acid base pair. So HCl Cl minus is one conjugate acid base pair, whereas ammonia and ammonium ion is another conjugate acid base pair. Clear? Let us discuss about the strength of acids and bases. So what is the present concept? Strength of acids and bases. So moving to the strength of acids and bases. So what do you mean by strong acid? So strong acid means an acid which has great tendency to donate a proton. To donate a proton. So what are the good examples of strong acids? It generally includes perchloric acid, sulfuric acid, HCl, HNO3, etc. Coming to the weak acid. Weak acid means an acid which has less tendency to donate a proton. So, an acid with less tendency to donate a proton is called a weak acid. In general, it includes acetic acid, carbonic acid, boric acid, phosphoric acid, etc. Coming to the strong base. Strong base means what is the nature of a strong base? Strong base will have great tendency to accept a proton. So, and the good examples of strong base includes especially here coming to the strong bases, it has a great tendency to accept a proton, and hence we have to consider CH3COO minus, HSO4 minus, HCO3 minus. They come under strong bases. Okay, moving to weak base. They have less tendency to accept a proton. So, what is meant by a weak base? Yes, which has less tendency to accept a proton. So, good examples are NH3, Cl minus, HSO4 minus, HCO3 minus. Let us move on to the strong bases. Especially it includes a conjugate base from the weak acids. So, it includes HCO3 minus but not H2SO4. And coming to weak base, it includes H2 NO3 minus. Clear? So, coming to the strong base, generally we will obtain from the weak acid by the donation of a proton. So, it includes CH3COO minus, HCO3 minus, H2BO3 minus, etc. And coming to the weak base, generally they have less tendency to accept a proton, NH3, and we can get conjugate base from the strong acids. That's why it is Cl minus, HSO4 minus, NO3 minus, etc. That is about the strength of acids and bases. And always remember one fact. So, weak acid has a strong conjugate base, whereas strong acid has a weak conjugate base. That means whenever if we consider HCl, it is a strong acid. So, its conjugate base is always weak in nature. And moving to the weak acid, that is CH3COOH, it always gives a strong conjugate base. So CH3COO minus is a strong conjugate base, whereas Cl minus is a weak conjugate base. That is all about the Bronsted and Lowry theory. Let us discuss about the merits and the limitations. So coming to the merits of Bronsted and Lowry theory, always it explains the acidic and basic nature of acids in non-aqueous solutions also. At the same time, it explains the relative strength of acids and bases. So what are the two merits of Bronsted theory? It explains the acidic and basic nature of acids in non-aqueous solutions also. At the same time, it explains the relative strength of acids and bases. And always remember, acid and base reactions are reversible. These are the merits of Bronsted theory. Coming to the limitations. This theory fails to explain the acidic nature of non-protonic substances such as CO2, SO2, etc. At the same time, it fails to explain the acidic nature of electron deficient compounds. So, electron deficient compounds means it generally includes BF3, AlCl3, etc. At the same time, it fails to explain the neutralization reactions which do not involve the transfer of proton. There is no transfer of proton from an acid to a base, but it is a neutralization reaction. So, Bronsted and Lowry failed to explain the neutralization reactions which do not involve the transfer of a proton. Clear? This is all about the Bronsted and Lowry theory of acids and bases. Now, let us move on to the pH. So, what is meant by pH? pH means it is the negative logarithm of H plus ion concentration. So, coming to the next concept, that is pH. So, pH can be defined as the negative logarithm of H plus ion concentration. And from this expression, we can calculate the H plus ion concentration as, so coming to the H plus ion concentration, it is 10 power minus pH. So, once we write an expression for pH, it is possible to write an expression for pOH, that is minus log OH minus ion concentration. So, that implies what is the concentration of OH minus? That can be written as minus pOH. Clear? And coming to the pH scale. pH scale was introduced by S.P. Sorensen. It always extends from 0 to 14. If the pH of the solution is 7, it is neutral in nature. And if the pH of the solution is less than 7, then the solution is acidic in nature. If the pH is greater than 7, the solution is basic in nature. Let us consider two solutions which are acidic in nature with pH 1 and 3. Then the solution with pH 1 is more acidic. Similarly, if we consider two different solutions in basic media, the solution with high pH value is more basic. So pH is very important. So always certain biological reactions takes place at a constant pH. Certain fermentation reactions, preparation of syrups, medical tonics requires constant pH. So the pH of the digestive system is 1.4. pH of the blood is 7.35 to 7.42, and it can be maintained by using carbonic acid buffer solution. So let us know what is meant by a buffer solution in brief. So coming to a buffer solution. So buffer solution can be defined as a solution which resists change in pH. The solution which resists change in pH value by the addition of little amount of strong acid or strong base or on dilution. So a solution pH value అయితే మనం కొంచెం స్ట్రాంగ్ యాసిడ్ కానీ బేస్ కానీ లేదా డైల్యూట్ చేసిన చేంజ్ అవ్వకుండా ఉంటుందో అలాంటి సొల్యూషన్స్ని మనము బఫర్ సొల్యూషన్స్ అంటాం. ఓకే, సో కమింగ్ టు ద టైప్స్ ఆఫ్ బఫర్ సొల్యూషన్స్. సో బఫర్ సొల్యూషన్స్ కెన్ బి క్లాసిఫైడ్ ఇంటూ two types. So buffer solutions are classified into two types. One being acidic buffer solution and the second one is basic buffer solution. So how an acidic buffer solution can be obtained? Always acidic buffer solution can be obtained by using weak acid and its salt prepared from a strong base. So how an acidic buffer solution can be obtained? Initially that can be obtained by considering a weak acid, and always its salt will be prepared from a strong base, and hence CH3COOH acetic acid and sodium acetate are good examples of acidic buffer solution. Moving to the other example, carbonic acid and sodium bicarbonate is good example for acidic buffer solution. Similarly, basic buffer solution can be prepared by mixing weak base and its salt prepared from a strong acid. That means, coming to the good example, ammonium hydroxide is the weak base and its salt will be prepared in HCl, that is NH4Cl, or its salt can also be prepared from other strong acids like nitric acid, then it becomes ammonium nitrate. This is all about the types of buffer solutions, and for the first time, according to Henderson, he gave two expressions for the calculation of pH and pOH for the buffer solutions. So coming to the pH of an acidic buffer solution, it can be prepared or it can be calculated by using the expression pKa plus log concentration of the salt divided by concentration of the acid. And coming to the pOH of a basic buffer solution, it can be calculated by using the expression pKb plus log concentration of salt divided by concentration of the base. So by using these two expressions, at any time it is possible to calculate pH and pOH of any solutions. And always remember, pH plus pOH of any solution is equal to 14. So this is all about the buffer solutions. Now it's the time to discuss in detail about the multiple choice questions based upon the Bronsted theory followed by other questions. Initially, let me discuss about the multiple choice questions based upon the Bronsted and Lowry theory. So, carefully listen to me. First question is, the conjugate base of HSO4 minus is. So, identify the conjugate base of HSO4 minus and tell me your answer. S. Be careful while answering. You have to identify the conjugate base of HSO4 minus. Conjugate base means what you are supposed to do? Base means Durga, carefully check your answer. Conjugate base means you have to remove a proton from the given substance. When you remove a proton from HSO4 minus, it becomes SO4 minus 2, and hence what is the right answer? At least now you can identify what is the right answer. Yes, very good. Option C is the right answer. So remember that conjugate base can be obtained by the removal of a proton, whereas conjugate acid is obtained by the addition of a proton. Okay, let us move on to the next question. Conjugate acid of NH2 minus is. So you are supposed to identify the conjugate acid. Conjugate acid means you have to add a proton. Very good, Swati. So you are supposed to add a proton, then it becomes NH3. Very good. Option B is the right answer. Very good. Next, let us move on to the next question. In water, the acids perchloric acid, HCl, sulfuric acid, HNO3 exhibit the same strength and it is called. So all these acids are strong acids. The strong acids are exhibiting the same strength in water. Then it is called as. Strong acids వాటర్లో సేమ్ స్ట్రెంత్ ఎగ్జిబిట్ చేస్తాయి, దాన్ని ఏమంటారు? ఎస్, వెరీ గుడ్. ఆల్ ఆఫ్ యూ ట్రై టు ఆన్సర్. వెరీ గుడ్, రమా దుర్గా. So it is called as leveling effect. So option B is the right answer. Yes. Suhani, very good. Next, here we go with fourth question. Conjugate acid of HPO4 minus 2. What is the conjugate acid of HPO4 minus 2? Very good. Swati. Priceless brains. Very good. Rama Durga. At once check your answer. Conjugate acid means you have to add a proton. Then it becomes H2PO4 minus. So in this case, option D is the right answer. Clear? Option D is the right answer. Let us move on to the fifth question. Why you people are not active in particular on this day? Okay, a conjugate acid base pair differ by A direct question. It is a gunshot question. A conjugate acid base pair differ by A. Very good. Priceless brains. Very good. Rama Durga. Hack. Very good. Suhani. Differ by a proton. So option B is the right answer. Coming to the sixth question. Conjugate base of a weak acid is. So what is the conjugate base of a weak acid? Hack. Very good. Priceless brains, you think at once and then answer. Rama Durga, very good. Swati, very good. But always remember, weak acid will always give a strong conjugate base. So option A is the right answer. Let us move on to the seventh question. Which of the following is a Lowry Bronsted acid? You have to identify Bronsted acid. So what is the nature of the Bronsted acid? What is the nature of the Bronsted acid? It can donate a proton. Now identify which of the following substances can donate a proton. At once think and answer. Bronsted acid means a substance which can donate a proton is called Bronsted acid. Now identify which can donate a proton. Priceless brains, very good. Rama Durga, very good. S. Option C, HSO4 minus is the right answer. Let us move on to the eighth question. The conjugate acid of ammonia is S. Suhani. Very good. Now you try to answer eighth question, that is conjugate acid of ammonia is. So what is the formula of ammonia? First you identify the formula, that is NH3, and you are supposed to find the conjugate acid. So conjugate acid means what you are supposed to do? No. Ramadurga, very good. Swati, very good. Suhani, check your answer. Hack, very good. Conjugate acid means you are supposed to add a proton, then it becomes NH4 plus. So option C is the right answer. One simple hint you always remember. What is that? When you are supposed to find out conjugate acid, you just add a proton. You just add a proton. If it is a conjugate base, you just remove the proton. That's it. Clear? Let us move on to the next question. According to Bronsted concept, water is. So what is the nature of the water? According to Bronsted concept, now tell me what is the nature of water. Whether it is acid or base or both or none, you have to identify. Hack. Mahendra. At once you check. Banu, very good. Suhani, very good. Rebecca, very good. Swati, very good. Listen to me. It can donate a proton and become OH minus, or it can accept a proton and becomes H3O plus. So it is having both acidic and basic nature. So option C is the right answer. Clear? Now tell me what is the conjugate base of OH minus. So when you are supposed to identify conjugate base, what you are supposed to do? Yes. Conjugate base means what you are supposed to do? No, Ramadurga. Check your answer. Suhani, you also check your answer. Very good. Priceless brains, very good. Swati, check your answer. Conjugate base means you have to remove a proton. Then what happens? Rebecca, check your answer. If you remove a proton, then it becomes O minus 2. Yes, Banu, very good. So option A is the right answer. What is the right answer? Option A. Coming to the 11th question, which of the following is a Bronsted acid but not a Bronsted base? What is the nature of Bronsted acid? Read the question properly. It is a Bronsted acid but not a Bronsted base. Now listen to me carefully. Coming to the water, it can donate or accept a proton. So this must be excluded. Coming to HCO3 minus. Same thing happens. It can accept a proton, then becomes HCO3, or it can donate a proton, then it becomes CO3 minus 2. So it is also having dual nature. Coming to the ammonia. So it can donate a proton or it can accept a proton. So it is also having dual nature. Coming to the H2S. It can donate a proton, then becomes HS minus. It cannot accept a proton. So option D, H2S is the right answer. Clear? Very good, Banu, Ramadurga, Rebecca, priceless brains. Very good. H2S is the right answer. So coming to the 12th question, the Bronsted acid which gives the weakest conjugate base. So you have to identify an acid which gives the weakest conjugate base. Very good, priceless brains. Listen to me carefully. So, when we are supposed to identify weakest conjugate base, that means we have to identify strongest acid. So, HCl is the strongest acid in the given options. So, option A is the right answer. Okay, Banu, very good. Let us move on to the 13th question. According to Bronsted-Lowry theory, in a neutralization reaction, I will read the given options. Option A, two conjugate acid base are formed. One conjugate acid base pair is formed. A salt is formed. Two salts are formed. You have to identify what happens in a Bronsted-Lowry neutralization reaction. Be careful. Will you try to answer? No, priceless brains. You just think. You better take one example. Rebecca, you are also not getting the answer. You take one example. HCl plus NH3. Then what happens? Yes, very good. So, Hack, Swati, Ramadurga, very good. Always two conjugate acid base pairs are formed during the neutralization reaction. Clear? Is it clear or not? Let me show that example. So HCl reacts with ammonia. Then what happens? HCl minus is one conjugate acid base pair. Ammonia and ammonium ion is another conjugate acid base pair, and hence it results in the formation of two conjugate acid base pairs during the neutralization reaction. Clear? Yes. Let us move on to the 14th question. An amphoteric species is. Now, what do you mean by amphoteric? I will read the given options. Option A, can readily accept a proton. Option B, can donate a proton. Option C, can accept a proton and donate a proton. Option D, neither accept a proton nor donate a proton. Read the given options carefully and then answer. S. Hack, very good. Bhanu, Swati, priceless brains, very good. So, amphoteric substance means it can donate a proton or it can accept a proton, that is having dual nature. So, option C is the right answer. Clear? Let us move on to the 15th question. Which of the following is a Lewis base but not a Bronsted base? You just underline. That is a Lewis base but not a Bronsted base. What is the nature of the Bronsted base? Can accept a proton. Isn't it? You have to identify which of the following will not accept a proton. No, priceless brains. OH minus will accept a proton and becomes H2O. You just think and then answer. You just apply Bronsted concept. Listen to me. Ammonia will accept a proton and becomes ammonium ion. Cl minus will accept a proton and then become HCl. So these two are Bronsted bases. Coming to OH minus, it will also accept a proton and becomes H2O. So calcium oxide is the one which is a Lewis base but not a Bronsted base. Clear? Okay. Till now we discussed about the multiple choice questions based upon the Bronsted and Lowry theory. And now it's the time to discuss about the multiple choice questions based upon acids and bases. Okay. In particular based upon the ionic product of water, pH and buffer solutions. Okay. Are you ready? Now, which of the following pair is amphoteric? Amphoteric means it can accept a proton and it can donate a proton. It must have dual nature and we have to identify amphoteric pair. So, both the substances should be amphoteric. Very good, priceless brains. Very good. Only priceless brains gave right answer. What happened to the remaining students? You have to check each and every substance. It must have dual nature. No. H2CO3 can donate a proton, will not accept a proton. Next, CO3 minus 2 will accept a proton but cannot donate a proton. Okay, H2CO3 will donate a proton, cannot accept a proton. Coming to HCO3 minus, it will accept a proton and it is capable of donating a proton. Then you have to check the second substance, H2O. Yes, it is capable of donating a proton and capable of accepting a proton. So option D is the right answer. Clear? Coming to the conjugate base of benzene in water. So you have to identify what is the conjugate base of the benzene. What is the formula of benzene? C6H6. Now identify the conjugate base of benzene. There is a small logic. You have to identify the logic. Then you will get the answer. You should be very careful while answering. It is not that much easy. No. Let me check who will give the right answer. No. Anyhow, I will reveal the right answer. Option D. There is no conjugate base for the benzene. Why? Benzene is aprotic. It will neither accept a proton nor donate a proton. So, conjugate base does not exist. Okay. So, option D is the right answer. Let us move on to the third question. At 90 degrees centigrade, pure water has H3O plus ion concentration as 10 power minus 6. Now find the value of Kw at 90 degrees centigrade. It is also logical question. You think twice, then answer. So at 90 degrees centigrade, water is having 10 power minus 6 mole per liter H3O plus ion concentration, and you are supposed to calculate the Kw at 90 degrees centigrade. Yes? No? You think twice or thrice. There is a simple logic. You have to catch that logic and then answer. No hack. Not at all, Banu. Yes, of course. Priceless Brains gave the right answer. Option B is the right answer. Now listen to me carefully. As the temperature increases, definitely Kw value increases. What is the Kw value at 25 degrees centigrade? That is 10 power minus 14. So it will be always greater than 10 power minus 14. Okay, that is one simple task. Next one is, in that context we can eliminate option C. But here what is the concentration of H3O plus? Indirectly they gave the concentration of H plus ions, that is 10 power minus 6. In pure water always H plus ion concentration is equal to OH minus ion concentration, and that is equal to 10 power minus 6. So you just multiply, then it becomes 10 power minus 12. So option B is the right answer. Clear? Suhani, very good. So whenever H plus ions are present in water, they associate with water and becomes H3O plus. Okay, in that way also you have to think. Clear? And remember one thing, in pure water the H plus ion concentration is equal to OH minus ion concentration. Clear? The sum of pH and pOH for given solution is, what is the sum of pH and pOH for a given solution? Hack, very good. Yes, Rama, Durga, Swati, very good. Always it is equal to 14. So option A is the right answer. Let us move on to the fifth question. Very good, priceless brains. Why you are slow? Next, the unit of ionic product of water is. Suhani, that answer is for fifth question. If it is for the fifth question, you have to post again. Ionic product of water. What is the unit of ionic product of water? Rama Durga, very good. You have to give the answer for fifth question, Suhani. Okay, you just try to answer fifth question also. But be careful while answering. It's very simple. Kw is equal to H plus ion concentration into OH minus ion concentration. In that concept, what happens? What is the unit of ionic product of water? Mole square per liter square. Very good, Ramadurga. Option A is the right answer. Direct question. Now tell me, what is the pH of rainwater? No, Suhani. What is the pH of rainwater? Very good, Swati. Ramadurga, very good. Ma, where are the remaining students? Why they are not answering? Yes, priceless brains, very good. Rainwater is the purest form of the water. For pure water, the pH is equal to 7. So, in that context, option D is the right answer. The highest pH value stands for. So, which of the following solution will have highest pH value? Neutral solution, slightly basic solution, acidic solution. What is your answer? Suhani, answer for the 7th question. Priceless brains, very good. Banu, very good. Suhani. Suhani, you try to answer for the 7th question. Very good, Suhani. So, highest value means pH equal to 14. Then what is the nature of the solution? Yes, undoubtedly it is the basic solution. So, option C is the right answer. Okay, let us move on to the 8th question. If the pH of the solution is 9.5, then the solution is. So, here pH equal to 9.5. And now tell me, what is the nature of the solution? Priceless brains, very good. Bhanu, very good. Ramadurga, very good. S. It is the basic solution. So, option D is the right answer. Let us move on to the 9th question. Which of the following mixture acts as a buffer solution? So, you are supposed to identify a buffer solution. Always remember, buffer solution will be prepared from the weak substance. Whether it is acid or base, it should be weak. So, we have to consider weak acid or weak base. That is the hint for 9th question. You try to answer. Priceless brains, very good. Hack. At once check and give the right answer. Ramadurga, very good. Suhani, very good. Bhanu, very good. Yes. Always buffer solution will be prepared from the weak substances. Here all of them are acids. Acetic acid is the weak acid and it's salt from the strong acid, that is NaOH, strong base. So option D is the right answer. Very good. Next, let us move on to the 10th question. The pH of an acidic buffer solution can be calculated by using which of the following formula? pH of an acidic buffer solution is equal to. What is your answer? It's very simple. Priceless brains, at once check your answer. In this class only, I explained how to calculate pH and pOH for the buffer solutions. No. Hack, very good. Priceless brains, very good. pKa plus log concentration of acid divided by concentration of the base. This expression is useful to calculate the pH of an acidic buffer solution. Buffer capacity of an acidic buffer solution is maximum when? Yes, you try to answer. Yes. What is your answer? Yes, Banu gave the answer. When pH is equal to pKa, that solution will have maximum capacity. Let us move on to the next question. That is 12th question. pH of soda water is. Banu Swati gave right answer. Now you try to answer 12th question. pH of soda water is. Very good, Banu. Banu, what is your answer? So what is the pH of the water? Generally it is 7. Soda water means we are adding acid. So it should be acidic in nature, that means it should be less than 7. So option A is the right answer. Okay. Banu, Suhani, they gave the right answer. Rama Durga, very good. Next, moving to the 13th question. The Bronsted acid which gives the weakest conjugate base is. So, weakest conjugate base is obtained from strongest acid. So, you have to identify the strongest acid. I think this question is repeated. Okay. Priceless brains, very good. The conjugate acid of. So you are supposed to identify the conjugate acid of S2O8 minus 2. So when you are supposed to identify conjugate acid, what you are supposed to do? Add a proton. That is the hint. Now tell me what is your answer. Very good, Banu, Swati. Very good, Rama Durga. Option C is the right answer. And moving to the last question, that is, which of the following is a Lewis acid? So you have to identify according to Lewis which of the following is an acid. Very good. Hack, Banu. So nice of you. So option C, carbon dioxide is an acid according to Lewis. Very good. Thanks for your active participation and have a nice weekend.